Professor Sati Umesh, and I'm going to teach the procedure for a gram staining. This technique of a gram staining was discovered by the great scientist Christiansen Gram, and this man or this legendary was from a Danish, and it was a one bacteriologist, and he gave us the technique about the gram staining. On his invention, he differentiated the two types of bacteria on the basis of a chemical structure of their cell wall, and he classified the bacteria into two classes, that means in gram positive bacteria and gram negative bacteria. Here are some examples of the gram positive and gram negative bacteria. If you look at to the left side, there is some examples of gram negative bacteria that includes the Aeromonas, Agrobacterium, Azospirillum, Bordetella, like or Bordetella pescis, Citrobacter, Enterobacter, Erwinia, Proteus, Pseudomonas, Salmonella, Serratia, Shigella, Xanthomonas, and Yersinia. These are some example of gram negative bacteria. Whereas towards the right side of the image, we can look for the gram positive bacteria. It includes the Bacillus, Brevibacterium, Corynebacterium, Lactobacillus, Mycobacterium, Rhodococcus, Staphylococcus, and Streptomyces. Also, some yeasts are there which shows a presence of such kind of gram positive bacterial cell wall. It includes a Candida and a Saccharomyces cerevisiae. The technique of gram staining is basically depends upon a chemical differences in between two cells. On the basis of a chemical difference, we can differentiate the bacteria into two classes, gram positive bacteria and gram negative bacteria, and their cell wall or a composition of cell wall is difference. In this image, we can look for the differences in between these two bacteria. If you look at the characteristics, first point, it is about the cell wall. Gram positive bacterial cell wall, it is a single layered and it has a size 0.015 micrometer to a 0.02 micrometer, whereas the gram negative bacterial cell wall is a triple layered and it is very small in that of the gram positive bacteria. Then next point, it is about the rigidity of a cell wall. The gram positive bacterial cell wall is rigid due to presence of a high amount of peptidoglycan, whereas the gram negative bacterial cell wall is elastic due to a presence of lipoproteins and polysaccharides. The third point, it is about the chemical composition. It shows a high amount of peptidoglycan in a gram positive bacterial cell wall, and it is 80% in a gram positive, whereas the amount of peptidoglycan in a gram negative bacteria, it is nil or it is 3 to 12%, whereas the presence of polysaccharide in a gram positive bacterial cell wall is 20%, and it also shows a presence of teichoic acid, whereas gram negative bacterial cell wall shows a presence of absence of a teichoic acid. Gram positive bacterial cell wall does not have any outer membrane, but the gram negative bacterial cell wall is with a outer membrane. The periplasmic spaces are absent in a gram positive bacterial cell wall, whereas such spaces are present in a gram negative bacterial cell wall. About a susceptibility to a penicillin, the gram positive bacteria are susceptible to the penicillin because the action of a penicillin is on a peptidoglycan. So, because of the presence of peptidoglycan, the gram positive bacteria are susceptible to the penicillin, whereas because of a lack of peptidoglycan in a cell wall of gram negative bacteria, they are low susceptible for the action of antibiotic penicillin. Then next, some differences are there which are in a nutritional requirement, presence of flagella and lipids and lipoproteins. In this image here, toward the left of the image, we can see for the procedure for a gram staining, and toward the right of the image, we can see for a difference in between the gram positive cell wall and gram negative cell wall. If you start from step 1, after a preparation of a smear, the first point is the smear is flooded with a primer stain, that is a crystal violet. The primer stain crystal violet is a basic stain, and this basic stain gives a color to both positive as well as negative cell. So both the cell get colored as a violet, and the crystal violet is applied for a 1 minute. After this application, if in a smear there is the presence of gram positive organism or gram negative, both the organism get colored, and the color of organism would be the violet. The primary stain in the staining is a crystal violet. The next step is a addition of a iodine or addition of a mordant. Mordant is a chemical that fixes a primary stain to the smear, and in the gram staining there is a mordant named as a grams iodine. This mordant grams iodine, it forms a CVI complex that is called as a crystal violet iodine complex, because of which the stain get fixed more amount in a cell wall of both the bacteria. In both the organism or both the bacteria, there is a formation of CVI complex. The next step is a wash the slide with alcohol or a decolorization with alcohol. And during this step or during the decolorization step, the only gram negative cell wall get decolorized from their cell wall or from their pores of a cell wall. There is a removal of a CVI complex, and so that these cells get decolorized only. And the reason behind it that the presence of a high amount of peptidoglycan in the cell wall of gram positive bacteria, and this shows a presence of high amount of cross linkage. If you look at to the middle of this image, step number 4, then we can get easily that how the cross linkage does not allow to remove the CVI complex. Only the gram negative cell wall allows to remove a CVI complex from it, and so that they get decolorized. If someone asks a question, what is the decolorizing agent in a gram staining, then question will be the alcohol. If someone asks you a question, what is a mordant, then the answer will be a grams iodine. Primer stain, that is a crystal violet, it is a basic stain. Then next, after decolorization, in this step of a decolorization, only the gram negative cell get decolorized and gram positive remains as it is. As it is means they remains as a violet in color. The next step is application of a counter stain or application of a secondary stain, and in this staining the counter stain is a saponin, or we can make a use of a basic phosphine as well. After application of this counter stain on a smear, as the gram positive bacteria already stained and they does not take a color of a saponin, but the already decolorized cell, that means a gram negative cell which are decolorized because of alcohol, they takes a color of saponin and get or colored as a pink. That means after a completion of a staining procedure, if in our smear there is a presence of gram positive bacteria, we can see for a violet color of that organism, whereas if in smear there is a presence of gram negative bacteria, then we can see for a pink colored organisms. That's complete the gram staining. And once again, hats off to this legendary scientist Christian Gram, and he developed this technique of a gram staining. Thank you very much.